Hey again everyone, thank you again for joining us, and now we're going to discuss organizing and summarizing data. Jumping into our section then, before we start the first objective, we introduce a quick little vocab word that would be raw data. And raw data is simply data that is not organized. Now going on to our objective, we're asked to organize qualitative data in tables now, which does have us presenting some more vocabulary first. The first vocabulary word we have would be frequency distribution, which would be a list of each category of data and the number of occurrences for each category of data. Now there's an emphasis here on the number of occurrences with what's coming later. The next concept to introduce would be relative frequency, which is the proportion or percent of observations within a category. We use the following formula to find this, where we take the frequency and divide it by the sum of all frequencies, and of course we'll demonstrate within an example. Connected to the concept of relative frequency would be our next term, which would be relative frequency distribution. Now this combines the idea of frequency distribution and relative frequencies. A relative frequency distribution makes a list of each category, just like a frequency distribution, but now with the relative frequency for each category. Now to do a quick comparison before we move on, since this tends to be a bit confusing, the difference between a frequency distribution and a relative frequency distribution is simply which values are listed. A frequency distribution lists the number of occurrences. The relative frequency distributions lists the percentages or proportions for each category. Jumping into our example then, we're asked to organize some qualitative data into a frequency distribution. They tell us the data below represent the colors of M&Ms in a bag of peanut butter M&Ms. They give us the raw data that's not organized for us, which means we would have to count this up ourselves because they're asking us to use the data to construct a frequency distribution and a relative frequency distribution. For the sake of saving time, you see the distribution tables have been laid out for us and the tallies have already been made. If those weren't there for us, we'd have to tally up the total number of each category. That is, we'd have to count up ourselves how many brown M&Ms do we have, yellow, etc., etc. Of course, that being tallied for us, we can go straight to the concept. Remember, frequency, since this is a frequency distribution, is a list of each category and the number of occurrences for each category we're discussing. Therefore, the number of brown M&Ms we have in our raw data would be 12, and we get to go ahead and list that as our frequency for brown. Yellow, according to our tallies that we see, gives us 10. We end up with 9 red, 6 orange, 3 blue, and 5 green, for a total of 45 M&Ms. Now we need that total, the sum of all the frequencies, because the next distribution table we need to construct would be a relative frequency distribution. So we repeat the frequencies for each category. And again, according to the definition, remember, a relative frequency distribution would be a list of the relative frequencies for each category. But the relative frequency would be the category frequency divided by the sum of all frequencies. So for our next column, the frequency divided by the total, we're saying for brown, we're going to take 12 and divide that by a 45 in order to get the relative frequency. That would give us a value of a 0.267, which is the relative frequency, or a 26.7% of the M&Ms were brown. Similarly, we do the same thing for the remaining categories. Yellow is 10 divided by our 45, red gives us 9 divided by our 45, orange would be 6 divided by 45, blue would be 3 divided by 45, and finally green would be 5 divided by 45. Doing the calculations and rounding to 3 decimals this time, we're going to end up with relative frequency of yellow M&Ms to be at 0.222. We end up with a 0.2 for red, but we're going to call that 0.0200, just to show the reader that we're still staying at 3 decimals. We didn't just decide to round to 1 decimal place. For orange, we end up with a 0.133. For blue, we end up with a 0.067. And for green, we end up with a 0.111. Moving on then, our objective asks us to construct bar graphs. Now a bar graph is constructed by labeling each category of data on either the horizontal or vertical axis and the frequency or relative frequency of the category on the other axis. The rectangles, which are the bars of our bar graph, are of equal width and are drawn for each category, and the height of each rectangle represents the category's frequency or relative frequency. Make sure we highlight that, the fact that we can create a frequency bar graph or a relative frequency bar graph. That takes us to our example. They've given us the M&M data again, where we have the frequency and relative frequency. Part A is asking us to construct a frequency bar graph, and Part B is asking us to construct a relative frequency bar graph. On to our construction then. First, working on the frequency bar graph. Just like we've stated in the definition, a bar graph is constructed by labeling each category of data on either the horizontal or vertical axis. So the first thing we're going to do is go ahead and label our horizontal axis with each of the categories of information that we have, which would be the different colors of M&Ms that we have. Which means next we want to label the vertical axis with the frequencies of each category, and we're going to go ahead and input those. Notice on my vertical axis, I've decided to make each hash mark worth 2, meaning 2 M&Ms for each hash mark, just for the sake of organizing and trying to make this graph a little bit better looking. Next would be to construct the rectangles of our bar graph. Remember, they're supposed to be of equal width, and the height represents the frequency of each category. Now we're drawing this by hand, so we're going to say these rectangles, the bars that we're constructing, need to be of equal-ish width. We assume that if you are creating a bar graph in a professional setting, there's no way you're going to be drawing something by hand. That being said, the frequency of brown M&Ms, meaning we had 12 brown M&Ms, so the first bar graph that we draw would be above brown, the category of brown, and we've got 12 of them. Notice that the height matches that frequency. Similarly, we had 10 yellow M&Ms, so we go ahead and draw that rectangle or bar at a height of 10, and then down the list from our frequency distribution. We had 9 red, 6 orange, 3 blue, and 5 green. Now the easiest thing to forget would be to label the axes themselves. So our vertical axis I'm going to label as the frequency, or in context of the problem would be the number of M&Ms. And on the horizontal axis we need to list this as the color of M&M. And we're all set with our bar graph. That takes us over to part B, where we need to construct a relative frequency bar graph. Very similar to part A. Difference now is that our vertical axis needs to be relative frequencies. So the first thing I'm going to do is still label the horizontal axis with the different colors of M&Ms that we have. And now my vertical axis is going to be proportions for each category that we have. So instead of counts that we had or current number of occurrences, these represent the proportions that we had for each of our categories. Of course, we still have this information in our relative frequency table, which means we can go ahead and start constructing the bars. For brown, we ended up with a bar between the 0.25 and 0.30 marks because the relative frequency of brown was a 0.2667. On to yellow, where we have a relative frequency of a 0.222. Red, we had a relative frequency of a 0.2000. Orange gave us a relative frequency of a 0.1333. Blue, we had a relative frequency of a 0.0667. And green, we had a relative frequency of our 0.111. So again, the height of the bar now represents the relative frequency for each category. Of course, the last thing we need to do is label those axes. So the horizontal axis I've labeled again as the color of the M&M for each category, but now on the vertical axis, like we previously stated, that would be the proportion of M&Ms rather than the number of M&Ms for each category. And we're all set. The next type of graph we're working with is called a Pareto chart, which is a bar graph where the bars are drawn in decreasing order of frequency or relative frequency. That is the only difference. A Pareto chart is still just a bar graph, but this unfortunately is an easy type of graph to forget. The example asks us to draw the frequency bar graph from the previous example as a Pareto chart. Now I'm going to cheat a little bit. I'm going to copy and paste, but it's only to show how simple a Pareto chart is, as opposed to letting ourselves get a bit confused by a new vocabulary word. Now here's the bar graph that we previously constructed. We've got the number of M&Ms and each category on our axes, of course. Again, the reason why I'm cheating here is, remember what a Pareto chart is by definition. It simply means we need to have these bars drawn in decreasing order of the frequency or relative frequency. This time we're working with frequency, so the only issue we need to worry about are these two bars. Otherwise, we've already got decreasing order. We simply need to take our category of blue M&Ms and swap positions with the green M&Ms, which you see me cheating and doing, and we're all set. Congratulations, you've got yourself a nice Pareto chart. Continuing on now, our objective has us constructing pie charts. Now a pie chart is a circle divided into sectors. This is typically a pretty commonly well-known graph, but each sector represents a category of data. The area of each sector is proportional to the frequency of the category in order to give us an accurate visual representation. You see the steps on your notes to construct a pie chart. Find the relative frequency of each category. Remember, the relative frequency will tell us the proportion. Multiply that relative frequency by 360 degrees to find the measure of the arc of the sector. And what this will do is give us a better picture of how big to make each quote-unquote slice of the pie. Step 3 tells us to use a protractor to approximate the angles of each sector. Now we're not going to use a protractor in our notes. Instead, we'll just be approximating this by hand. And lastly, we need to make sure we identify each sector and label the percentage or proportion. Taking a look now at our example, they ask us to use the previously obtained M&M data to construct a pie chart. Now we have our relative frequencies for each category, which was our color of M&Ms, of course. And now we just need to take those relative frequencies and multiply by a 360 to approximate the degree measure so we can split up our circle correctly. Multiplying the relative frequency for brown by 360, we end up with approximately 96 degrees. And we'll go ahead and get our degree measures to the nearest integer since we're just approximating the sectors of the pie chart. We need to multiply each relative frequency by 360 degrees. So for yellow, we end up with 80 degrees. For red, we end up with 72 degrees. For orange, we end up with 48 degrees. For blue, we end up with 24 degrees. And for green, we end up with 40 degrees. Taking our degree measures to construct our pie chart then, since we're just approximating this by hand, I'm going to go ahead and split the pie chart into 4 sectors, just for the sake of visual. Now for brown, we have a 96 degree angle measure, and if you don't remember your geometry days, that's just a little bit bigger than 1 quadrant of the circle. So I'm going to say 96 degrees is about here. Now I'm going to erase those quadrantal lines just to get them out of our way, since we have our first sector on the map. The next category would be yellow, accounting for 80 degrees of our pie chart, which puts us about here. After yellow, we've got 72 degrees for red, which is 20% of our data, putting us about here. Following red, we have orange. That needs to be 48 degrees in our pie chart. Of course, that means blue goes on to our 24 degrees, the smallest slice of our pie, if you will. And finally, that remaining section should be green. If we've approximated it in the right ballpark, we end up with about 40 degrees. And we've got ourselves a nice, beautiful pie chart. That takes us to our next topic, which would be side-by-side graphs. These graphs can be used to compare 2 data sets on one graph. The graph should be drawn using relative frequencies to deal with the possibility that data come from samples or populations of different sizes, and it gives us a good comparison. You see the example already. They give us data that represent relative frequencies of the marital status of U.S. residents that are 18 years of age or older in 1990 and 2006. So we've got 2 different sets of data that we're discussing, and we're asked to draw a side-by-side relative frequency bar graph of the data. Now as we construct our graph, the first thing we want to do is make a legend, so we can make sure we're completely clear on which category is represented by what figures. Now don't worry if you have different colors. But for the 1990 data, I'm going to use blue, and then we're going to throw those nice little slashes through our bar. And for 2006, I'm going to use red, and I'm going to throw a nice little squiggly down the middle of my bar. Now, don't feel self-conscious if your bars don't look as beautiful as mine. Remember, I am a licensed professional. Continuing to our graph then, remember this is still just a bar graph like we've done previously. It's 2 bar graphs within one. The first category would be never married. In 1990, about 22% of people were never married, so we draw our bar at about the 22% height. And then in 2006, just over 25% of people were never married. Notice that we've drawn our bars side by side over the category that is never married, and it allows us to create a nice comparison within each category. We do the same thing for the remaining 3 categories. In 1990, almost 62% of people were married, and then in 2006, just over 58% of people were married to create our comparison. In 1990, about 7.5% of people were widowed, and in 2006, just over 6% of people were widowed. Finally, in 1990, we have just over 8% of people were divorced, while in 2006, just over 10% of people were divorced. And we've got ourselves a nice side-by-side bar graph. And thank you again for joining us.